Well, hello, and welcome to this PowerPoint presentation on the skeletal system. And I just want to say from the start that this PowerPoint is designed for an introductory level high school anatomy class, which is the class that I teach. And Actually, this PowerPoint presentation is designed specifically for my anatomy students. However, if you're not one of my students, then I'm sure you'll be able to derive some benefit from this presentation and hopefully give you a better understanding of the skeletal system. So let's get started. You'll notice on the first slide, and this is for nearly all the slides as we go through this PowerPoint, there are blanks, and those blanks are there because I use that as a teaching tool for my students when I'm normally teaching them in class. However, of course, I'm not in class right now due to the current pandemic, but perhaps if you aren't my student, then you could try to guess what the answers to the blanks are before I give them, and in a way quiz yourself, and hopefully that'll be beneficial to you and provide you with some help as we go through this, and then you can kind of test your understanding of your knowledge of the skeletal system. So let's begin with the 5 basic functions of the skeleton. First of all, the skeleton provides us with support. And so you think of all the bones that are within us, and the human body has 206 bones. They're all, for the most part, providing in some way some kind of support for the body. So it's holding us up, and it's resisting the force of gravity, and it also provides support for muscles and connective tissues that also then secondarily will help support organs of the body as well. So skeleton primary function, one of the 5 primary functions then would be support or structure. You could say structure as well. Second function would be protection. So the skeleton offers the body protection, protects the organs that are within the body. And you can see, for example, in the top picture, where there's the picture of the rib cage kind of wrapping around from the vertebrae around to the front and attaching the ribs attaching themselves to the sternum. And within that, and you look at it, it kind of creates a cavernous void within the body that can be then filled with organs. Namely the lungs and the heart in this particular instance. And so the ribs provide protection for those those vital organs of the body. Third main function would be hematopoiesis, which is the formation of blood cells. And that's what the graphic on the bottom displays there. It's trying to point out to you that from the bone marrow, within the medullary cavities and the empty spaces within the spongy bone, we have these hematopoietic stem cells that are forming. And from those stem cells, all of the other blood cells are derived. And they'll go through the process of cellular differentiation and become the different types of blood cells that are utilized throughout the body. And that hematopoiesis is just a term for blood cell formation. And the prefix hema refers to iron. And iron is carried within the bloodstream, so that's where that prefix is coming from and referring to. You think of a blood doctor, so to speak, a hematologist is a blood specialist. And so this particular medical specialist has that prefix as well for their title, referring to the blood. Stores mineral salts, primarily calcium and phosphorus salts. So those 2 elements, then, we consume them in the foods that we eat, and the foods get broken down into their constituent parts, and the calcium and phosphorus then gets deposited from the bloodstream into the bones of the skeleton, and then the bones then become a repository for these mineral salts that we will then use later for nerve conduction, muscle contraction, the building of the nucleic acids, for example. And so the bones then become a storage place or a warehouse for these mineral salts. And finally, 5th primary function is to provide sites for muscle attachment. And you'll notice that the picture on the top, you can see how the large latissimus dorsi muscle is attached down many of the bones of the spine and then comes across the pelvis and then attaches also up on the humerus as well. So the bones then provide sites for the muscles to attach themselves to via tendons. And then those muscles will pull on bones, and then we get movement from that. And so the muscles themselves have numerous sites to attach themselves to, and then that increases our range of motion and enables us to move in all the variety of ways that we do. Now, the skeleton is divided into two major parts, or two major divisions. There's the axial skeleton and the appendicular skeleton. So the axial part refers to the axis, or you think of like the axis through the earth. It's running through the center of the earth, and that's what the axial term refers to. So in this picture here, you'll see the axial skeleton is in blue, and the appendicular skeleton is colored pink. So the axial consists of starting at the top, the skull, then the lonely hyoid bone, which is in our throats and covers our larynx, the vertebrae, which are, of course, the spinal bones, and then the rib cage or the thoracic cage. So those then would be the bones of the axial skeleton. The appendicular skeleton, it consists of our limbs, the arms, and our legs, and then the pelvic and pectoral girdles and all the bones that are associated with those two locations of the body. So we're talking pelvic around in the pelvic bones themselves, around our hips. And the pectoral girdle is referring to our shoulders, where our clavicles are and our scapulae. So those bones up there in the shoulder. So two major divisions, axial and appendicular. Let's look at some bone anatomy. So periosteum, and just so you can see in this term, and we're going to see it throughout this PowerPoint, you'll see that those letters OST, ost, which refers to bone. There are cells, for example, mature bone cells that are called osteocytes. So when you see those letters used as a prefix or a suffix, it's referring to bones. So the periosteum is a tough outer covering, and peri means around, and that's why it's called that, because it's the outer covering that goes around the bones. It's made of fibrous connective tissue. So it's made of tough fibrous connective tissue. It's very thin, but very tough as well. It contains blood vessels that enter and service the bone cells. So they're bringing in nutrients from the circulation, and they're bringing those nutrients into the bone cells that are within the bones themselves, bringing much needed nutrients and oxygen to the osteocytes, which are the mature bone cells. The medullary cavity is the inner cavity of what's called the diaphysis. So the diaphysis is better known as the shaft of the bone. So think of the classic example, the femur, our thigh bone. So the long middle portion of the femur is called the diaphysis, and it houses yellow marrow. Yellow marrow is abundant in adipose or fat cells. Now, it's not entirely yellow. There is red marrow in there, but predominantly within the medullary cavity, you would find yellow marrow. The epiphysis is the end of a long bone. So, using the femur as an example, the femur would have two epiphyses. There would be a proximal up at the hip, the head of the femur, and there would be the distal, which is down in the knee. And that contains the epiphyseal disc, which is a region of growth or mitosis. Cell division is what's going on there in the epiphyseal disc, also better known as perhaps maybe the growth plate. And so there we have it's a layer of hyaline cartilage in which cells are dividing rapidly. And we'll talk about the epiphysis and as it enters through the influence of hormones, the end of its growth phase, which is late in our late teens, is when that begins, and then progresses for a few years after that, until it is no longer active and it becomes a just an inactive region of the epiphyses. It's made of or consists primarily of spongy bone, or another name for spongy bone is trabecular bone. And it's covered with articular or hyaline cartilage. Now, articular and hyaline, they're the same thing. It's not like it's articular or hyaline, but otherwise known as hyaline cartilage. In fact, the entire skeleton in our was in our uh, fetal development, when we were a fetus, was entirely hyaline cartilage. And within there we have red marrow. And this is where hematopoiesis occurs, in the red marrow within the epiphyses and other regions of the body, but it's not just, hematopoiesis is not just occurring in the epiphyses, but that's an area where it does occur. The diaphysis is the middle shaft of the bone, and it's mostly compact bone. And it does have some spongy bone or trabecular bone, but it's mostly compact. Compact bone is also known as cancellous bone as well. So just other terms that you may run into: spongy, trabecular, compact, or cancellous. Either one of those two, they're synonymous for those different types of bone. And so you can see in this cross section of a femoral head, so somebody must have had a hip replacement done, or some orthopedic work done on the proximal end of their femur. And you can see in the cross section, as a bone saw has cut through that, how you can see the outer surface of the bone where the periosteum would cover that, and then the red marrow and a little bit of yellow marrow right in the center, in the heart of the femoral head. And so you can see how the adipose gives it that yellowish color to the yellow marrow. So we don't have entirely red marrow in one location, or only entirely yellow marrow, but the two of them kind of are found together. So good picture of the femoral head looking down into it. Some other terms related to bone anatomy: the endosteum. And so endo, or END, is referring to within. So the endosteum is the inner lining of the medullary cavity. And it's connective tissue covered with simple squamous cells. So simple squamous is a type of epithelial tissue, so there's some filtration and absorption protection going on with this cellular layer of simple squamous cells, and it's highly vascular. Highly vascular means it's full of blood vessels. So, for example, a vascular surgeon's specialty is working with blood vessels, knowing where they are and what regions of the body those blood vessels serve. Canaliculi. So these are microscopic openings within bone tissue through which bone cells connect with each other and to the blood supply. So remember, bone has a pretty significant non-living part to it. And that would be the hard part of the bone, the calcium and the phosphorus salts. We call that the matrix of the bone, the non-living substance that comprises this bone. And bone, by the way, is a type of connective tissue. As I said, it was hyaline cartilage, goes through the process throughout our lives of becoming ossified, or the process of ossification. And so it remains a connective tissue. So once the matrix then, which is the hallmark of connective tissue, once the matrix begins to ossify, there needs to be a way for the cells that are alive within the matrix of the bone to receive their nutrients and oxygen. And so in order for little microscopic blood vessels to get through, and nerve tissue, or nerve fibers to get through, there are canaliculi. So these are tiny little openings through which they can pass. And then lacunae, which are microscopic chambers that house osteocytes. And osteocytes are mature bone cells. And so these are tiny little chambers in which the mature bone cells, the osteocytes, will be located. And so here you can see a femur labeled with its variety of parts here. So we have articular cartilage at the end, we have the proximal epiphysis, and at the opposite end we have the distal epiphysis, and in the center is the diaphysis, or the shaft of that bone. There's spongy bone at the ends and predominantly compact bone in the center. Medullary cavity housing yellow marrow wrapped around with the periosteum. Spongy bone in the epiphyses, and you can see the epiphyseal discs that are located there at the proximal epiphysis, the area where there is growth occurring within those bones. So so you can see what we were just talking about, and it helps to visualize all of those anatomical terms. Now, as I said, there are two main types of bone. There's spongy bone, which it has many spaces within it, which then lowers the density. So the spongy bone having a lot of open spaces in it is going to reduce its density, and those spaces then are filled with red marrow. And there are these cross struts, I guess you could say, that are found within spongy bone, and the trabeculae give strength to the spongy bone. So yeah, it has a lot of spaces in it, but it's got these cross members that are going back and forth in diagonal patterns and giving a lot of strength to that spongy bone. Compact bone, on the other hand, is dense and it lacks spaces within it. It has a central canal within a unit of compact bone, and we'll talk about those in a minute, which house blood vessels and nerves. So the central canal is kind of an open area within a subunit of the compact bone. Compact bone is made of these concentric layers that are called lamellae, forming around the central canal. So that is what I was just speaking about. A subunit of the compact bone is called the Haversian system, or it's also called an osteon, which are layers of bone, the lamellae, going around the central canal. So think of like a tree stump. You can see the rings of the tree going around and around each year, developing a new layer around them. That's what the Haversian systems look like as well. These Haversian systems, or osteons, are closely packed together, tightly packed, hence the name compact bone. And so it develops its compactness from that. And you can see in this the cutaway of the femur on the left, that would be the which epiphysis, proximal or distal? That would be the proximal epiphysis, where there's an abundance of spongy bone, and then you can see where the compact bone is labeled as well. And then up close microscopically, you can see, and I put brackets around one of the Haversian systems, or osteons, what one of those subunits looks like. And then in the middle, there's a central canal through which blood vessels and nerves can travel to service the bone and give nutrients and bring oxygen and take up carbon dioxide from the metabolically active cells. As we put our bones under stress, they respond by making more osteons to strengthen the bone, to enable it to withstand the greater amount of stress that we're putting on our bones. Say, for example, if we're a long-distance runner with the constant pounding on the pavement, which then will thicken the bones and create more dense bones, because it's responding to the amount of stress that you're placing upon the bones of the skeleton. And here you can see another picture of it with internal bone anatomy, where we're looking at they're kind of like showing an osteon popping up out of the compact bone there, with the canaliculi, which are the tiny little microscopic ones that are running through there to allow capillaries to get through. And then you have the central canal, and it's showing that red tube and the blue tube. That would be a small arteriole and a small venule running through there. And then you can see all the other ones that are packed in beside it. There's one down in the bottom right there, Volkmann's canal, which is a horizontal linkage between two central canals that are running vertically there as well. So there's more connecting going on between them. They just don't exist as independent entities, but they're connecting to each other as well. And I think that's a good place to stop for now. So I should have mentioned that. I apologize at the beginning of the PowerPoint that I'm going to split this up into two parts. So we'll say that's the end of part one, and then I will later then post part two. I didn't want to give you too much at once. So hope you enjoyed part one, and hope you're looking forward to part two. And thank you for watching.